Hey there, my name is Prabhat and I'm a TKS innovator. And as part of my learning into the area of artificial intelligence, I'm doing my second project, which is a neurosymbolic AI system that can generate mocktails for users based on their preferred flavor profiles. And so before I get into like the specifics of what exactly my project is and how it works, let me just give you a little intro about the concept of neurosymbolic AI. So, neurosymbolic AI, as it sounds, is a combination of two different areas of in AI, which is neural AI and symbolic AI. So, neural AI is the subset of AI that consists of neural networks, which are artificial neurons that are modeled in a way similar to our brain, and they work well in identifying patterns in large data sets and getting information from them. An example of this is using an image recognition algorithm to like predict if it's a cat or a dog. So that's like how neural networks work. On the other hand, symbolic AI is more based on like using logical reasoning and deduction to kind of make conclusions or get new information from what we already have. And an example for this is for very simple one is that, for example, if a person is eligible to vote, and then there's like this rule that says if it's above 18 he can vote, if it's less than 18 he can't vote. And that's like an example of a very simple symbolic AI system. And it can be like much more advanced, and like I'll give you an example about it later, but this is like how symbolic AI works. So, and neurosymbolic AI is the combination of doing both. So from in this specific context, a neural network can learn from the previous choices and make recommendations, but the symbolic reasoning part can kind of make sure that it when it makes recommendations, it kind of stays inside the boundaries and the particular logical constraint that it's enforced. And how exactly this is being done, I will be explaining later. And a few important things that if you're seeing like this for the first time, few important things to know. Deep learning is a specific subfield of machine learning that involves training these neural networks with the large amounts of data to make accurate predictions. Neural network is a specific type of algorithm that is modeled after our brain, and this is how it works. And yeah, and for when I say symbolic reasoning, in my case, I'm using a rule based system, which is a set of if then rules to make decisions and draw conclusions. So, this is it. So, to explain, to like put this in context, let me give you an example. And I really like this example of to define what a new symbolic AI system is. 'Cause, so, imagine a detective trying to solve a crime. So now they have access to like a lot of evidence, witness statements. They have like a lot of information about the case. But now to solve the case, he's going to need to have two things. One is logic, the other one's intuition. So using logic, he kind of eliminates these possible aspects, scenarios that don't make sense. But at the same time, he uses intuition to make connections between like the evidences that might seem unrelated, but at the end up solving the case. So, in a similar way, a neurosymbolic AI system combines two different approaches to solving a problem: symbolic reasoning and neural networks. Okay, so now that we've gone through what neurosymbolic AI as a concept is, let's look at the specifics of my project. So, one of the fun things about like this project, like right as we start, is that this was like one of my first times where I've like actually properly used a GPU. Usually it's on my computer, because what happened this time is I had to run the model on like a lot of combinations. So it took like intensive computational power, and that's when I realized that what exactly GPU I had used, how exactly to use it. And this is like the very first step of the project, which is installing the TensorFlow GPU, because I built my model on Keras. So now, yeah, this is just the installation. There's an error, but then at the end, finally it's installed. It's good. So yeah, and now for the important packages. So first, NumPy is a standard package, and which is a standard package I use in like every project because it's useful for manipulating numerical data. TensorFlow for building the model, Pandas for getting the data in, Tools and Random is for generating the mocktail combinations and selecting them. And these are just for the model. I'm using a Keras sequential model urge user, and I'm using the dense dropout batch normalization as well as an early stopping. And I will be explaining what these are in detail when we get to the in the code. Um, this is a statement that is needed to understand what to make the model run on the GPU and not on the CPU. So we set image data format channels last. It means that it runs on the GPU, which we've just installed in the previous block. So yeah, and here's the data set. So for the first one, for the data set, I have created a data set using ChatGPT from getting data set. So these are like the name, the ingredients, and what flavor profiles, and a randomly generated user rating. So for this case, we're using something random, but in like a real world use case, we could use real world ratings. And like after this, for like each one of these recipes has been like checked. So like each one of these are legit. So there's about 100 recipes which we have, and there's like no null values. The reason why you check for null values in the beginning is that if there are any, it could lead to like a huge problem in like the neural network when it runs. So that's why you're just checking. And is there like any duplicate value? It kind of shows false. Checked it in detail, but this just like show that it's false. And now we're starting with like over here, because in mocktails, so like from while doing this project, I went into like specifics of like how mocktails are created, what are the formulas, and like what I realized is that these are like the three main types, which is sweet and sour, creamy and refreshing, bitter and refreshing. These are like the main type. And so this is how we create like flavors and the complementary flavors, and this is how they work. And for refreshing, it's bitter, but refreshing could also be creamy. But yeah, this is what we've set it with. And now, a fun take on this as well is that these statements are generated by ChatGPT and kind of modeled after Ryan Reynolds. So like I had these basic statements that said like these are the options, choose from sweet, sour, and these are the options. And then there's asked ChatGPT to put like a Ryan Reynolds spin on it because I'm a huge fan of Ryan Reynolds. But and like this is what we ended up with. And so yeah, and now if we get the user's taste, we just assign them to flavor one and flavor two, and we just set it. But for example, but if they want a custom, we kind of get let them select which one and make sure that it's valid, which is why we're checking if it's valid or not. And then once you get the valid, we recommend them to choose a complementary one. So if you choose sweet, we'd recommend sour because because that's what like is most common. But if they don't, we just go along with what they want. And now we've so for example, for my example use case, I've chosen. So now I've chosen the first one, which means I've chosen the classic sweet and sour combo, and it says you have refined palate. Okay, that's just me. But um, this and now we move on to like checking for the flavor. So for the first one, we check if it's any of the user's preferred flavors, and then we return all the ingredients that have the user's preferred flavors. And if there's any ingredient that the user doesn't want, we check that as well. And we finally get a list of 60 ingredients because that is a lot when you come by and when you look at the potential capacity it to like 60 ingredients. And if you like just take a look at it, most of these are sweet and sour, like lavender simple syrup, lime, lemon lime soda, no jalapeno, no beetroot. Like these are most of them are in what the user wanted, which is sweet and sour. And we don't have to worry about like the ones that do not match it because we will be using symbolic reasoning for this specific purpose. And now we are generating all possible combinations using these three ingredients. So every single combination of mocktails. So for us, we're just using like three ingredients to like design what kind of mocktail it is. And over here, we finally get all mocktails. And the reason why I said like 60, we're limiting it to 60 ingredients is when you get a combination of three from 60, which is this is a concept called combinations, which is like 60C3, and you end up getting 34,220 combinations. So these are the total number of combinations that can be generated with all the ingredients that we have. And now with symbolic reasoning, I've given like an explanation over here, but what it exactly does is it just looks at the different flavors and kind of makes sure that the ingredients that we put fit the flavor profile, and at the same time make sure that they are like actually they can actually they are like valid and they would taste good based on like the user rating. So now for over here, how exactly I'm doing it is, so if the user, let's say, wants only a creamy, we make sure that there's like no jalapeno or soda water in it, because jalapeno or soda water not creamy. And we make sure that there's yogurt, coconut milk or coconut cream, at least one of that inside, so we make sure that it is um, a creamy mocktail. And same goes for like the sour. For sour, we're looking at ingredients that are not sour to make sure that they're like not in the combination. And for sweet, it's the same thing. We're just making sure these elements, these ingredients are not there. And now we now is where this all happens, and now we just make sure, once again, these are all the sweet ingredients, all the sour ingredients, all the cream ingredients. We just make sure that for each of them there aren't more than two of the same, because even if it's sweet or sour, even if it's creamy and refreshing, we don't want two of more ingredients. We want it to be balanced, so we're just making that, so ensuring that too. And then now for the specifics, for sweet and sour, we make sure that there's like only one sweet, one sour, and then we have something called a balancing ingredient. So once again, like doing my research for like doing mocktails, I got this list of like very specific balancing ingredients that are required for any kind of sweet and sour mocktail, and we make sure this happens. And then same for creamy and refreshing, bitter and refreshing. And this is why the reason why I like offer the main three. And of course, after, if you do custom, the results will be based entirely, it will kind of make sure that you kind of have only one on one, but the balancing ingredient is kind of not so. So that's why the custom is not exactly up to the mark as these three. But the major part of the symbolic reasoning component is this, where we just add random, which not random, we just look at two different ingredients that cannot be mixed together. So bananas and bananas and blueberries cannot be added because their flavors may clash. Maraschino cherry with lime juice may not complement each other well, so we just remove any kinds of combination that has this. And that is what all this is about. This is just using expert rules. And now this is a tedious and long process, like checking if these ingredients, checking, making sure that none of these pairs are in it. So which is why it's much more simpler in the long run to use ontologies or knowledge graphs for the model itself to it can reason by itself from the graph and say that okay, these two cannot be added. And that is kind of what I'm doing in my next project. I'm not generating mocktails, I'm using knowledge graphs in a different way for my next project. But for this, we're just using an if then system as the symbolic reasoning component. And now if you see, after everything, we've got 522 possible combinations. So 522 are like the feasible number of combinations, and these are like the combinations that actually fit the profile and would actually taste good. And now we've got, and after this, once again, we get now is where like the neural component of it comes into play. And for the neural component over here, we get a list of all the ingredients. We convert the input to like how the neural network would get it, and we split it into train and test data sets. So we split it into like train and test data sets, and now we convert the inputs using our function grow to input to neural network inputs, and we finally get it as a this is where the numpy array comes into play, where we like kind of make it into an array. And now we use the neural model. So for the neural model, we're using a sequential model that adds dense layers. So of dense layers of 256 neurons in the first layer, and 128 in the second, 64 in the third, and 32 in the fourth, and one at the end. So the reason why we're using just one dense layer at like the end is to like this linear function gets the final predicted rating of like the combination, and that's kind of what we use. And to like make sure the user gets a mocktail that is suits what he wants and is like kind of highly rated as well. And over here we're using early stopping. So early stopping is a mechanism in which the model kind of stops training if there is no improvement in like the loss, of there's like no improvement after a certain amount of time. And that's what we're doing. And now model fit. we're just fitting with like the inputs and the targets and making sure that it's like we fit it with like the x and y, so the model knows that for this is what the prediction looks like. And then now this is the function, and so this is like evaluating the test loss, and over here this is the getting all the flavors and the ratings. So now we're using the neural network to predict, so we use the function of the model dot predict function to predict based on the input. So now based on what the user gave, what the user gave is in the function called combination, so in the variable for combination, and we use this, and now we kind of figure out the best rating. So now you can see the training. We've initialized it for 100 epochs, which means 100 iterations, but it stops over at 33 because there's no improvement after that. And if you take a look over here, we are getting these as the best combinations, and finally we get a combination of beetroot juice, orange juice, and vanilla extract, which is a 4.61 expected rating. And now this is just another one, another simple method. It's kind of to just to name the mocktail. I know like the mocktails in the dataset actually had kind of really good names like apple cider spritz, pina coladas. These are like classy names, but yeah, when it's like a limitation, we could use like something like ChatGPT to come up with a creative name. But I was trying to use a rule based system to add to make the names as well. And this is what a rule based system for coming up with names looks like, and just like initializing it for all. And finally you get something like I suggest this mocktail made up of this, and it comes up with the name Scrumptious Delight Mocktail.